Hello, all of you. Now, welcome to our new topic. Last class, we have started this electromagnetic induction, and there we have discussed about the Fleming's right-hand rule. According to Fleming's right-hand rule, if you stretch the finger of right hand mutually perpendicular to each other in such a way that the first finger will show the magnetic field, the thumb will show the direction of motion, then the resultant current will be shown by the center finger. This is the first finger for field, this is the thumb for the motion, and this finger will show the induced current. Why it's induced? Because there is no any direct contact between these two, the magnetic field and the motion, but then also we are getting the current, so it's a induced current. Fleming says this principle helps the engineers to design the electric generator. So, what is electric generator? Electric generator. First of all, we have to remove the confusion in its name. Does not generate anything. It's only converter. It's convert the mechanical energy into electrical energy. And how does the conversion take place? By that simple rule that if a closed loop of conductor is placed in a magnetic field, this is the magnetic field, then induced EMF will be produced in this conductor due to change in magnetic field. These lines are magnetic field lines, which you have started on our first video of this magnetism chapter. So changing magnetic field will induce current in this circuit, and this phenomenon is due to EMI, electromagnetic induction. Changing magnetic field produces induced EMF, and that is known as electromagnetic induction. So what we used to do in a generator, one coil is used to rotate, and when the coil is getting rotate, it is brought in contact with the magnetic field, and there is the generation of induced current. That motion of conductor is changing the magnetic field, because when we are inclined to some axis or armature, the amount of current gets changed there. So, what is the function of electric generator? What do you write? Function. Function of generator it converts mechanical energy into electrical energy. What is the principle of it? Principle of electric generator, that is, it works on the principle of electromagnetic induction. This is the principle of electromagnetic induction, helps to design a generator, and the function of generator is it converts mechanical energy into electrical energy. Please pause the video and write down the things. Okay. Now we'll move to the construction of a electric generator. Here today we are talking about AC generator. So AC generator. First of all, like the electric motor, we will place two strong electromagnet. One is having north pole and another is south pole. Now one armature is designed here, and the armature is carrying two wires, and these two wires are kept with two coaxial slip rings. Slip ring. slip ring S1, this is slip ring S2. If you have any problem, please zoom the things will be visible to you. And the slip rings are connected with the carbon brush as it is like the electric motor. Carbon brush. This carbon brush is B1 and this one is B2. Now these two are connected with an electric bulb. Electric bulb. What is the function of slip ring? So S1, it allows the constant contact of armature with brush. S1 and S2 both. S2 and S1 both allows the contact of this armature and brush. Just like if this is the slip ring, then this rotates like this. So always there is a direct contact between this the armature, this is the slip ring, this is the armature, so there is always a contact. If this contact will not there, then everything will be just zigzag. So what? The entire circuit will get damaged. So slip ring provide a direct contact between the brush and armature. What does the brush used to do? Brush is an alignment between slip ring and the external load. So B1 and B2, B1, B2, B1, B2 provides regular contact between slip ring SLIP, slip ring and external load. External load means things of our house, the fan, the bulbs, all those things. So this is the construction of an AC generator. Here we used to keep the axle. In a generator, you have seen that when we move the nozzle of the generator, this coil start to move, and as the coil start to move, the motion get changed and the magnetic field of this armature get changed. Now what's happening there? Please see. This armature is of soft iron. Their soft iron are there, rectangular plate, and their copper coil are wounded over there. This wounded copper coil. So what it happens? These things also carry on. So soft iron is a ferromagnetic material and copper coil is also a supportive them. So amount of change in magnetic field will be more by making this turn. More will be the number of turns in this soft iron, more will the change in magnetic field, and so the induced current will be also more. So now we'll move to the working of this generator. Please see, please write down the things. Just pause the video and write down the things. Okay. Now move to the working of the generator. Working of generator. If again we are mentioning this A, B, C, D, please see this one, A, B, C, D. This one is A, B, C, D. When the axle is moved, due to this north pole, the axle is getting downward direction. So as it is getting downward direction, a certain period comes when it's come to the straight point, then the amount of magnetic field start to get changed because the polarity of the north and south will get exchanged. Okay, this one is the things when it is getting down, going down, then it is going far. This surface is going far from this node. So the amount of magnetic field of this arm will get reduced. But as the motion is continuing due to the axle, so at the same instant it will go to that direction. So this face will go to this direction and this face will come to this direction. So the contact of this S1 and B1 will exchange the amount of magnetic field on the given circuit. As the magnetic field is changing, the induced EMF is producing, that is EMI. So by changing the rotation of this armature, change the magnetic field, and changing magnetic field produces electric current. So this is the working of electric generator. Here why it's a AC generator? Because the touch of this S1 is continue with B1 and S2 is always in contact with the B2. So the polarity gets changed due to change in the magnetic field. I will provide you the working on the notes. So you will write the working from that note, but this is the outcome of the working of AC generator. Now we'll discuss about AC. What is AC? AC is alternating current. Alternating current. How I define? Alternate means one after another. So the current whose magnitude change alternately and direction change periodically are termed as alternating current. Here the magnitude is not constant. It is not like DC current. The magnitude will continue go in a straight path. Here the magnitude is changing like this one. Sometimes it's above at this area, no current is there. Again the current is in another direction. Now these people of this area or circuit of this have the current, but as it will move to this area, again there will be no current. Again the current has come here. So this area the current will be there, but no current in this area. Next it is going to this area. In this area there is no current, but current is there. So what is happening? Current is maximum to minimum, again maximum to minimum, maximum to minimum, maximum to minimum. So the current is changing, the magnitude is changing alternating, plus minus, plus minus. So this type of current is AC. This one is DC. Please revise this much. I will provide you the notes. There you write down the things of the working of the AC generator, and electric current is alternating current is mentioned here. So please pause the video and write down the things. Now from DC motor and AC generator, one question is asking everywhere in the board examination. So please take this topic very much seriously and compare both the diagram. There you yourself will see what is the basic difference on the construction of DC motor and AC generator. Till then, thank you.